Welcome to EPG Pathshala. In this module, we are going to discuss about Introduction to Optimality Theory Part 1. What is the system of knowledge? How did this system of knowledge arise in our mind? How do we put to use this system of knowledge? What are the physical mechanisms that are responsible for this system of knowledge and putting it to use? Whereas the generative grammar tradition can account for just the first question, Optimality theory, also known as OT, can account for all the four. Optimality theory is a general theory of cross-linguistic variation and a formal theory of linguistic typology. It is used not only in phonology but also in other areas of linguistics such as semantics and syntax. In this model, we are going to discuss about OT in depth, how OT works, what is the architecture of OT, who are the major contributors of OT, and the basic thing that OT deviated from rule-based phonology on the basis of constraints and not rules. So we are going to talk about these constraints in detail, the markedness and the faithfulness constraints. Now let's start to understand the subject in detail. OT is essentially an alternate view to phonology. This theory was developed as a response to a conceptual crisis at the center of phonological thought by Prince and Smolensky in 1993 concerning the role of output constraints. The noticeable familiarity with the ideas of optimization, competition, parallel evaluation along with conflicting constraints strongly suggests that the optimality theory framework was at least partly inspired by the concepts of neural networks. OT is a general theory of cross-linguistic variation and a formal theory of linguistic typology. Moving on to the major contributors of OT, Alan Prince of Rutgers University and Paul Smolensky of Johns Hopkins University, both in USA, started introducing their studies on a new approach to language. This new approach was named Optimality theory by 1993 and became quite well known by Prince and Smolensky's widely circulated manuscript Optimality theory. Constraint, interaction and generative grammar. The impact of this pioneering study in the field of phonology was far-reaching, intense and instantaneous. Further, since its inception in early 1990s, Optimality theory has been adopted in many other areas of study within linguistics, including syntax, semantics, historical linguistics, social linguistics, etc., and even beyond the discipline of linguistics. During and after the initial phase of inception, John McCarthy, Linda Lombardi, René Caguet, and many other scholars contributed significantly in the growth of optimality theory. It is no wonder OT is considered one of the top 5 developments in generative grammar in recent times. Moving on to the architecture of OT, phonological constraints are ranked and violable by the phonetic forms of their underlying representations in the OT structure. So basically what OT has is constraints that are universal and which are violable. Now, and these are ranked hierarchically. These constraints are minimally violated by a set of candidates, and the one which incurs the least serious violation wins. So basically in OT there are a lot of potential candidates. Now these potential candidates fight with each other to become the optimal candidate. Now the optimal candidate is one that incurs the least amount of violation and the least serious violations, which are not that costly. So if an optimal candidate is the one that violates the least ranked constraints. The seriousness of violation is defined in terms of hierarchies of constraints. The violations of higher rank constraints is considered to be fatal. And there we use a tableau to harmony maximization as the criterion for optimality, where the weights are in the top row and the rightmost column provides the harmony values for the candidates. According to Caguet, the inevitable violation of a constraint does not imply ungrammaticality, whereas the absolute satisfaction of all constraints is crucial to the grammar's outputs. Now moving on to the architecture of OT, we have Lex, the gen, the eval and the con. The Lex stands for lexicon, the gen for the generator, the eval for the evaluator and the con for the constraints. Now lexicon is, or Lex is one where the underlying forms are there. The lexical representation or the underlying forms are there. Now these serve as the input to the generator. Now the generator accepts the input. Now the generator forms various candidates, potential candidates, and sends these potential candidates, which is like an infinite set of candidates, to the evaluator for the evaluator to evaluate. Now the generator has generated infinite number of potential candidates and sent these candidates to the evaluator. Now what the evaluator does is evaluates the most optimal candidate based upon the ranking of these constraints. The candidate that incurs the least serious violation is chosen by the evaluator as the most optimal candidate. A candidate X is optimal if and only if for any constraint that prefers another candidate Y to X, there is a higher ranked constraint that prefers X to Y. Now con stands for constraint. It is basically Markedness constraint and faithfulness constraints. Now OT has two kinds of constraint, which is one is the Markedness constraint, the other is the faithfulness constraints. We are going to talk about this later on, but now I'm just going to give you a brief idea of what these constraints are. Basically, Markedness constraints are the well-formedness constraints and the faithfulness constraints are the correspondent constraints that seek for identity between the input and the output. Now before moving on, it is very important to know two actualities. First, that constraints are violable, but the violation must be minimal. All constraints are violable. There is no such constraint that is not violable. Every constraint has to be universal and it should be violable, but the violation should be minimal. That is, the least ranked constraints could be violated by the optimal candidate. And the ranking process of the constraint is very crucial to get the optimal output. Every language has its own specific ranking. This ranking, it's language specific and it is very crucial in OT as well as to the language itself. So constraint ranking for language L. Now if there is an input, then there are potential candidates, as you can see, candidate 1, candidate 2, candidate 3, and there are constraints, constraint 1, constraint 2, constraint 3. Now you can see candidate 1 violates constraint 2, candidate 2 violates constraint 1 and candidate 3 violates constraint 3. Now since candidate 1 and 2 violate the higher ranked constraints, these violations would be called as fatal. Whereas candidate 3 violating the constraint 3 is not fatal and hence chosen as the most optimal candidate. In the graphic representation of OT structure, you can see there is an input which is basically from the lexicon. Now this input goes to the generator. Now the generator accepts the input and forms different potential candidates, which is like candidate 1, 2, 3 and 4. Now these candidates go to the eval for evaluation. The evaluator, based upon the constraint ranking and the constraints in hand, it evaluates the most optimal candidate and therefore we get the output. So there is another graphic representation for the Hindi word kela, banana, in which there are different constraints in how the working of OT happens, how it goes to the generator, how generator generate candidates. You can see the n number of candidates there. There are 5 candidates and there are different constraints, and finally you get the output, which is the optimal candidate. Now we are going to talk about the constraints. Now, as we said, that OT has constraints and not rules, and these constraints are universal and have their own ranking. They are violable. These constraints are universal, they are violable, and they have a ranking of their own, which is language specific. And the candidate that incurs the least amount of violation or the least serious violation is chosen as the optimal candidate. Now, what are these constraints? Like, what are the types of constraints? As I said, there are two types of constraints. One is the markedness constraint and the second is the faithfulness constraint. The constraints in OT can be categorized into two major groups, namely as above. As described by Krennic-Hager, unmarked values are cross-linguistically preferred and basic in all grammars, while marked values are cross-linguistically avoided and used by grammars only to create contrast. So basically, since markedness constraints are well-formed constraint, they give rise to unmarked values, whereas faithfulness constraints maintain that lexical contrast. Markedness constraints enforce well-formedness of the output candidate, prohibiting structures that are difficult to produce or comprehend. For instance, Kager lists some of the common markedness constraints across many languages. A. Syllables must have onsets. B. Vowels must not be nasal. And third, obstruents must be voiced after nasal sounds. Moving on to faithfulness constraints. Faithfulness is understood as the combined grammatical factors that preserve the lexical contrast. They demand similarity between input and output candidates. Here is a list of some of the typical examples of faithfulness constraints. First, that output must present all segments present in the input. That is, there should not be any kind of deletion. Output segments, second, output segments must have counterparts in the input. That means that there should not be any kind of epenthesis. And the third, the output must present the linear order of segments in the input. The linearity sequencing or the linearity order of segments in the input should be maintained in the output. Like, for example, metathesis is not allowed. Now moving on to know how OT works, let us take an example of the English pluralization. In English pluralization, we know that, for example, like book becomes books, whereas dog becomes dogs. Now, the plural morpheme here has two allophones, sir and z. Now, basically what happens is that the plural morpheme agrees in voicing and then you get the two allophones depending upon that. So now we have to prepare a constraint set. Now, what are the constraints set? There has to be a markedness constraint and there has to be a faithfulness constraint. The markedness constraint basically is about agreeing in voice, that the agree in specification of voice, and the faithfulness constraints we can have that no deletion, which is max IO, dep IO, which is like no kind of epenthesis going on, and ident IO for the feature voice. Like if the feature voice is present in the input, it should also be present in the output in its correspondent. So the grammar for this language that could be constructed so far is presented in the following ranking. Now, what is the ranking? That is max IO is the most higher ranked constraint, followed by dep IO, followed by the markedness constraint agree voice, followed by the ident IO faithfulness constraint for the feature voice. So basically what we are trying to say is that there has to be no kind of deletion, no epenthesis, and the feature voice has to be markedness constraint, it has to agree with the feature voice, and the faithfulness constraint opposes this, that the contrast should be maintained. If there is voice in the input, it should be also in the output. Now we know the underlying morpheme for the plural morpheme is z. Now if you take the input as book followed by the z morpheme, you have four potential candidates. One is the bookies, then there is books, and then there is books, and then there is book. Now with the constraint ranking, given that max IO followed by dep IO followed by agree voice followed by ident IO voice, we have the most optimal candidate to be B. Why? Because we can see that A violates dep IO, because there is an insertion in A, the E vowel is inserted, so that is a fatal violation of dep IO. In C, you can see that the agree voice, the markedness constraint is not agreeing, like z is plus voice, whereas k is not voiced. So there is no voicing agreement there, therefore C violates agree voice, which is another fatal violation. And in D you can see there is deletion. The z morpheme is itself deleted, the plural morpheme. So max IO is deleted. So B, since it incurs the least serious violation, which is the faithfulness constraints violation to the corresponding feature voice, therefore B is the most optimal candidate. Similarly, in dogs also you can see the same thing, that A, B and D incur fatal violations. As in A, there is we can see epenthesis going on there, and in D there is deletion going on, the plural morpheme is deleted. In B, voicing is deleted, not deleted, the voicing is not being agreed. Sir does not agree with G with respect to voice. So therefore that, and then Z becomes voiceless. So ident IO is also getting violated there. The Z morpheme becomes Sir. So ident IO is getting violated there, and C has no violations at all. So C is the most optimal candidate. Again gives a very useful factorial typology of markedness constraints and faithfulness constraints. So what he says is, if the markedness constraints, which are context free, dominated by the context sensitive markedness constraints and faithfulness constraint, there wouldn't be any variation. Those gives rise to only unmarked structure, because the well-formedness constraint is dominating, so there won't be any kind of variation there. Now, if a context sensitive markedness constraint dominates a context free markedness constraint and a faithfulness constraint, there can be allophonic variation, which we saw in the previous example of English pluralization. There was kind of an allophonic variation because the agree voice markedness constraint was a context sensitive constraint. And if a context sensitive markedness constraint dominates a faithfulness constraint, and which dominates a context free constraint, we can see a positional neutralization. In one particular position, the sounds neutralize, that there is no difference between the sounds in a particular position. And finally, if faithfulness constraint dominate all the other, we can find full contrast or full lexical contrast. In this module, we discussed about optimality theory in detail. We saw the various components of OT, which were the lexicon, the generator, the evaluator, and the constraint set. We talked about the constraints, which is the core of optimality theory in detail, the types of constraint, the markedness constraint and the faithfulness constraints. We also saw how OT works, how it chooses the most optimal candidate. We took the example of English pluralization to account for the allophonic variations in languages. Optimality theory gained immense popularity not in phonology, but also in syntax, semantics and other interdisciplinary areas. I hope this module was of great help to you. Thank you.